All right. Hi, good morning. My name is Ville Laitinen. I'm from the University of Turku in Finland, and today I'll be talking about a course that we planned on the Carpentries platform of Stan. So a few years ago, during my PhD studies, I was given the responsibility for running a course on probabilistic data analysis, and in practice that meant giving a Stan course for an audience as wide as possible. So of course nowadays, students from basically any background may need to do some data science in their studies, in their research, and at the same time, the appropriate courses may not be part of the study programs. So we thought about addressing this by offering something that was maximally approachable for students from basically any background. That was the aim anyways. When we started thinking about which material to use, the Gelman's PDA was the obvious first choice, but on the other hand, it's maybe a bit too theoretical and maybe not computationally oriented enough. Statistical rethinking is another favorite in our group, and that was actually used for the first iteration of this course in a university, but that relies on a higher level R package, whereas we wanted to get students actually building Stan programs. So my supervisor then suggested that we do our own material on the Carpentries platform. So he's a certified Carpentries instructor, and that's why he suggested it. And there was no Stan program on the Carpentries platform available at the time. So the Carpentries is a non-profit organization that teaches these foundational coding and data science skills in workshops around the world. It's volunteer-based. All of the materials are open source and developed by the community. And they're very much proponents of these evidence-based pedagogical practices like very hands-on, interactive lecturing style and live coding and so on. There's currently a few dozen workshops in the official curriculum, but quite a few more in the Carpentries incubator. And so the incubator is the place where the material development happens, and there you can find courses or course materials at various stages of development. And that's where our course currently lives. And of course, we are aspiring to make our course eventually part of the official curriculum. And there you can see some numbers about the Carpentries as well. So here in this flowchart, we can see the current structure of the course. So each of these boxes is an episode. So Carpentries courses consist of episodes, and each of these boxes represent one. So you can think of them basically one lecture's worth of material or a section in a book. So we begin with the basics in Bayesian thinking here. The very basics, introducing the likelihood function and the prior function, and what sort of information they encode and how they lead to the posterior, and how you can communicate posterior information, and then fitting some super simple models with the grid approximation and quickly noticing that life is very difficult if we rely on that only. That is not feasible in practice, and this way motivating the usage of sample-based strategy. Then we move into the Stan episode. Again, just the basic functionalities are presented there. And the idea is that once you have this basic package under control, then you can move into this bigger box where the episodes are sort of modular, so you can choose which ones you want to include in your course. So yeah, these are the ones that are currently available, but more episodes are being developed all the time. About the course philosophy, so like I said, we wanted to cater to an audience as wide as possible, and this means that the prerequisites need to be minimal. So basically, if you know some basic R coding and you have a basic understanding of what statistical modeling is, then you should be able to follow this material. Secondly, we aim for the material to follow the hermeneutical spiral, needing for example, that in the STAN episodes we only present the very basics, and then in the consecutive episodes there's more sophisticated techniques introduced. But yeah, because the intended audience is wide, some compromises need to be done, and in practice this means like sweeping a lot of the theoretical details under the rug, and also using mainly simulated data. And like I said, we wanted to teach the students how to build actual STAN programs, so that there's some level of intimacy between the modeler and the actual statistics, even though we don't really manipulate any formulas in this material. And yeah, we also have an episode on STAN extensions, including VRMS, but that's not what the other episodes do. And then we also provide reading instructions for reference books for the more technically oriented students, where they can, find theoretical details and other relevant information. Yeah, so that's the basic course structure. And yeah, this is planned so that we have the MCMC episode on hierarchical models and model checking. They're of course not unimportant, but then the material is such that they are not essential for following these episodes that come after this STAN episode. So for example, if you're unable to follow MCMC, then you're still able to learn about Gaussian processes. Then we can zoom into one of the episodes. So this is the beginning of the STAN episode. That's what it looks like. So here we also have the list of currently available episodes. So there's 9, the last of which is a set of exercises. And each episode begins with an overview box where we define the learning objectives and study questions. And after that comes the main text, which is basically just rendered markdown code with some special ingredients, like the callout block you can see here. So the callout block is something that sort of interrupts the main storyline to give you some additional non-essential information. Then we can scroll down the episode. Here we present the basic STAN program structure. And if you can, I'm sure you can notice that the level of verbosity is minimal here. Yeah, so that's how we introduce STAN programs, and then we quickly go into actually building some very simple models. So here's the first example is the beta binomial model, which was also used actually in a previous episode. So that's hermeneutical spiral in action. Then we can scroll further, and here we see some other special ingredients, that is the challenge boxes, which are basically exercises that are meant to be done during the lecture. And here the challenge is to implement linear regression in STAN. And each episode ends with key points. And that's what the students see. But there's also another sort of hidden layer, which is the notes for instructors. So here we've listed some things like, what the students may find difficult, or where you should maybe dwell on for a little longer. What are like non-essential information that is nice to know, but can be skipped without any harm. Yeah, so that's the course in a nutshell, and we're semi-actively developing it further by improving on the existing material and also extending it. And a lot of this development is based on the student feedback that we gather from students after each iteration of the course. And for many students, this course has been their first exposure to Bayesian thinking and STAN, and in general the feedback has been overwhelmingly positive. So students like to use STAN, and but there's some like recurring themes in the feedback that I've listed here. So of course, because we have a very wide and diverse student base, there's different needs, and the theory is one of those. So of course, like the more technically oriented students, have felt that this is a bit superficial, but we're trying to address this by adding some theory in the callout blocks, and that way also making this material more like all-encompassing. Another common complaint is that while simulated data is nice to work with because you can sort of the ground truth and you can test whether or not your model actually works, but some students feel that this approach is a bit detached from reality, and we're working on adding some real data examples there as well. One thing that has been found almost universally confusing are priors, and that's sort of understandable because we just mostly tell the students which priors to use, and that's understandably a source of anxiety, but we're trying to address this as well by adding an episode on priors. And the nice thing is that many people have also wanted to learn more, so extension course has been requested, and we're trying to make this happen next year, hopefully, and that would mean we need to get active with the episode development, and here are some possible topics. So there's no shortage of those, but we need to just decide which ones we want to include. All right, thank you.
Great, thank you very much for a lovely talk. I'm going to open the floor to questions. Oh, there's one right up in the middle there for you. Thanks.
Yes, thank you. I was wondering, you said that the sort of thirst for theory was very variable. How is the thirst for working with R as opposed to Python, for example, which is something that I constantly discuss with my engineering colleagues?
Yeah, so some students have actually completed this material using Python, but also several computer science students have been grateful that they can actually learn R while going through this course. So, yeah, I mean, the actual R coding is quite elementary here, so you should be able to do it, in your language of choice.
Makes a lot of sense. Any other questions? There's one down here at the front.
Thanks. It's interesting. I'm in the process of developing some courses, so I'll probably steal.
Do you mind speaking a bit closer into the
microphone?
microphone?
Sorry.
Thank you.
It's really great, and I'll probably use some of your material in my teaching. That's
Nice.
really cool. I guess at the risk of losing my stats license in this audience, why teach the MCMC bit at all? Like when we teach frequentist statistics, we don't teach them about optimization usually. We don't tend to go into the details of all of that. Have you thought about just teaching it from we don't worry about the MCMC part, we just, here is the model, we're just going to do Bayesian statistics and don't worry about any of this other stuff.
Yeah, I think this is partly because of my background. Like when I started my PhD studies, I had never written a single line of code, and when I started using Stan, it threw some errors at me that were really, giving me anxiety. And the point of the episode is to show how your sampler can go wrong. So you have some sort of intuitive understanding of what the errors from Stan actually mean. Yeah.
Thanks.
Oh, there's a couple of rows back there as well.
Thank you for the talk. I was wondering, is this a self-paced course, or is there lectures, live lectures happening?
Yeah, the way that we used this so far is that there's lectures which more or less correspond to the material in the Carpentries thing, but like I said, we're trying to make it such that it would, be an entity of its own. So you could learn all the necessary things just following this, but I don't think we're there quite yet. So this is sort of just to support my lectures so far. But moving in the...
If it's okay, then like the add-on question would be, how do you ensure kind of student activity, so engagement, and kind of is it something that you see that this course creates a space where it's easy to ask questions, or are students hesitant to open up about the issues that they are encountering?
Yeah, this is something that I really do think about. And well, one of the techniques that I use is I deliberately make mistakes myself during the lectures. So I think that is a step towards a safe environment where the students can also make mistakes, you know. Yeah.
Thank you.
That's great to see. And perhaps I could ask one maybe slightly different question. Obviously, you're coming at this from a bit of a pedagogical angle and the teaching perspective. Mm-hmm. In the world where AI is becoming ever more prevalent, I know it's not specific to what you presented here, but how do you think having access to all of this material is going to make it harder to do assessments and such like that for your students going forwards?
Yeah, so far there has been no like an exam on this course. Okay. It's been a final assignment, which is basically a set of a bit more difficult exercises, and it's very clear that everybody returns an AI report. And then a few years ago, this was not possible because AIs were not, good enough solving the problems, but now they are. So what we are actually going to do is, starting next year, there's going to be an exam in addition to the final assignment. So that's one way to control it. Mm-hmm. And also the demo sessions, students have to present their own solutions. So that's one situation for me to grill them, to definitely see if they're actually done the work themselves. But definitely a challenge.
100% no. Good to see that you're coming up with some live solutions, I guess, to verify these things. Are there any final questions in the room before we head to lunch? No, perfect. Well, let's thank all of our speakers once again, and we'll congregate at 1 o'clock. Thank you all.